physicist is sent to a small planet to conduct some experiments. He found that for an object of 2 kilogram mass, tossed straight upward with an initial speed of 14 meter per second, it takes 9 seconds to hit at the ground. Radius of the planet is given, so we need to first find the acceleration due to gravity on that planet. So it is thrown with a speed of 14 meter per second, goes up and comes down, and this complete cycle takes 9 seconds. Okay. So let's see what equation can be used to find the value of g. Um, I think we can use the first equation of motion because we know that whatever velocity with which it has been thrown, this with the same velocity, with the same speed, is going to come just in the opposite direction. So if we use the first equation of motion, that v is equal to v naught plus at, final, let's consider the downward direction as positive. So final velocity is 14, initial is minus 14, a is unknown, and time is 9. So 28, adding 14 both sides, 28 is equal to 9a, and dividing both sides by 9, we have the value of a as 3.11. So the acceleration due to gravity is 3.11 meter per second square. In question number 2, compute the mass of the planet. So we know that the formula for the acceleration due to gravity on the planet, on any planet, is given by gm over r, right? uh, is gm over r. So in this case, we already know the value of a. I missed one square over here. It's actually gm over r square. All right, so if you flip the equation, then gm over r square is a. So the value of the mass of the planet is a r square over g. Acceleration is 3.11. R square is 3.18 times 10 raised to 7 whole square, 3.18 times 10 raised to 7 whole square, and g is 6.67 times 10 raised to minus 11. So this value comes out as 3.18 square. I'm just doing everything using a calculator, of course. So this value is coming as 4.72 times 10 raised to 25. 25 kilograms. So that is the mass of the planet. Okay. And then we have to find out what is the speed of an spacecraft if it is moving in a circular orbit 30,000 meters above the surface of the planet. So what is the speed? So the formula for speed of such an object or satellite on a planet is given by gm over small r. The small r is the distance from the center of the planet. So that's going to be the radius plus its height. We know the value of g as 6.67 times 10 raised to minus 11. Mass is 4.72 times 10 raised to 25 over r plus h. What is r? R is the radius of the object of the planet, pardon, which is 3.18 times 10 raised to 7. It's 3.18 times 10 raised to 7 plus its height, and the height is 30,000. But just be careful about the units over here. This is given in meters and this is in kilometers, so we got to convert that in meters as well by multiplying it with 10 raised to 3. So this is the required speed in meter per second. So again, let me just try to simplify this. 6.67 times 4.72 comes out as 31.4824 times 10 raised to 14 over 3.18 times 10 raised to 7 plus 3 times 10 raised to 1, 2, 3, 4. 4 and 3 becomes 7. Okay. So this will become, I think these are kind of with the same power, not kind of, they are with the same power. So these can be added with the same, keeping the power as same. So this will become 31.4824 times 10 raised to 14 over 6.18 times 10 raised to 7. So this value comes out as over 6.18 times 10, and the square root of this value comes out as, so finally the answer comes out as 7.14 times 10 raised to 3 meter per second. Or this can also be written as 7.14 kilometer per second, but that's not a great way to represent. Or if you want to get rid of the power of 10, it can be written as 7137.39 meter per second as well. So either we can write like this, or we can write as a power of 3, perhaps in a scientific notation like this as our final answer. Thank you.